My name is Nikon Razumov, and thank you very much for having me talk about AI data, privacy, and fairness. Just a quick disclaimer, all the statements and ideas that I present here today are my own views and do not represent the views of my employer. Before we start, let me introduce myself briefly. I hold a PhD in computational neuroscience. I hold a patent in automatic vendor detection for cybersecurity vulnerability. At Symantec, I developed the cyber insurance vertical, and Alexa Voice Shopping, I supported the trust and safety team. Cloudflare bot management is one of my products that I developed. And at Facebook, I'm responsible for AI data and feature engineering. Of course, I don't have to explain you that machine learning and AI are all around us. When it comes to finance, loan applications, HR, job applications, when it comes to self-driving cars, but also the insurance products, medical, X-ray predictions, commercial recommendation of products, and customer experiences. All of them use machine learning. But what about the privacy and fairness implications of those products? Before we jump into the requirements, I want to play a game. Imagine right now in the room, in the conference, we would like to know who are the people, what fraction of the people believe in vaccines. Now, of course, this is a very sensitive information, and no one would like to share this information just publicly. But there is a technology called differential privacy that in the first step introduces a bit of noise and then combines that with your information and allows us to compute what is the average number of people in the conference right now. So let's play a game. Let's imagine in the first step, by introducing noise, we will just imagine whether it's a head or tail. Just flip a coin in your head and remember your choice. Then answer the question truthfully. Do you believe in vaccines? And then in the step 3, combine those two informations and raise your hand if you flipped tail in your head, the random information, and if you believe in vaccines. If you combine those two and you raised your hand, we are now able to compute what is the fraction of people in the conference that believe in vaccine, and we are also able to compute what fraction of people don't believe in vaccines. Now, you can, of course, see the advantages of differential privacy, but also some of the disadvantages. Let's look more into depth into other privacy requirements. That's, of course, not an exclusive list. First one is the lineage tracking. All information used from a customer's perspective to make predictions, to train a model, to make inferences, all the parameters need to be tracked in a lineage system, but also extends to who were the labelers, where they came from, what decisions did they make when they made a human annotation of your dataset. The second requirement is purpose limitation, probably one of the most interesting ones, because when the customer gives you their data, they would like this data to be used for a specific purpose that they express, for example, security, user experience, or maybe to get better predictions on their recommendations. However, it's a very difficult problem because when you have a machine learning algorithm, from our perspective, it looks a little bit like a black box. You don't really know what's happening inside and how the data is being used and aggregated. Of course, you can manually go through each algorithm, but as soon as your company has more and more algorithms, thousands and maybe 10,000s of models, you need a system that can systematically look into an algorithm, uncover the black box, maybe like a config file, something that is really clear to the machines. This data is being used for this purpose, and it is also being aggregated. That's why it's okay to use this data. The next requirement is data minimization. What can you do to predict with and how little data can you use for it? Finally, the last two requirements are unauthorized access, most famous one probably because of the machine learning breaches and cybersecurity industry, but of course, including scraping of content that you made publicly available. The last requirement is retention. When you want your data to be given to a machine learning and then you change your mind, you have the expectation that this data will be deleted. How are some of these requirements achieved? Of course, when it comes to lineage tracking, you need to just record all the data and meta information in a data set and make sure that all the machine learning parameters are recorded. When it comes to purpose limitation, you need to annotate the policy this data is for security purposes, then track them inside the features and uncover this black box. And then you need to make sure that all the data sets are also correctly annotated. This is something that we are very proud of. Data minimization. Of course, data minimization can be achieved using federated and differential privacy, but I would suggest that even if you use federated learning, you still need purpose limitation, because even if you use the data on the device, it could still be against the customer's desires. And then we have unauthorized access. Of course, there is an entire industry, so-called cybersecurity, but there's also newer products like bot management that are developing to protect the authorized access. The last one is the retention requirement. Now, of course, you can just delete the data, but I think that's important to note that you might also have to retrain your model. And in that case, you need an automated system that retrains models and refreshes them based on customer deletions. Before we jump into the next topic, let's play another game. Imagine you are trying to predict what should be said in the following sentence. Fill in the word. Women tend to be more than men. Of course, this really depends on the algorithm and the data that has been used to train this. If the data had a certain bias, you will also have a biased prediction. What can be done about this? These are some of the requirements. Label imbalance is one of the first problems that I think could arise. When you have a certain data set and a certain hateful percentage of comments comes from a certain gender, that means that if you started going out and making predictions on the other gender that is underrepresented in your data set, maybe those predictions are not accurate. Label bias is another requirement. When you have a systematic bias in your human labelers, when they have a certain preconceived conception, or maybe they haven't experienced certain information in their group, they might produce biased labels. Very difficult to detect. And then the last one is the model bias. When the model is making predictions for a particular subgroup and rejects and makes decisions much more often than for another subgroup. What can be done to address all these requirements? Now, the first one is something that we've been developing for a while now, called odds ratio. It's the combination of a particular label, maybe reject a loan application, accept a loan application, and the subgroup that this label represents, right? So for example, you have a gender subgroup, you have a skin color subgroup. This odds ratio allows you to identify a label imbalance and then use that to maybe fix your data set and sample more data for the subgroup. Label bias, of course, you can also use gold data sets, but they're very hard to come by. And diverse sampling based on the odds ratio is a way to improve the solution. And then the last one is model bias. Model bias is if you will have to monitor your predictions that you're making by the individual subgroups. Now, let me thank you again. My name is Nikon Razumov, and please reach out if you have any further questions.